Welcome back with Kamira. In today's episode, we are going to look at file organization or file structure for Flutter project with clean architecture. Our interest is not just coding, but we need to be professionals in our way of working. Therefore, it is important that we arrange our code to the standard, or we arrange our project as to the standard. So I've shared from the lib directory, because in the lib directory is where most of the work happens, given the fact that we can also do some work in the various folders like iOS, Android, and so on. So the focus of clean architecture is in here. It is important to have a clean architecture because of some of the following things that I'm going to talk about, whereby the first one is separation of concerns. When you separate the concerns, for example, log in and register and then make order, you realize that it becomes very readable or easy to debug in case of any fault. Clean architecture makes the code easy to test. Secondly, it makes the code scalable. You can easily expand your project basing on the features. Better team collaboration. Also, it is very easy as a team to collaborate on a given product. If you have a shopping product, big as it is, you can put in mind one of the shopping products you have in your country. And then you, a developer, given a task to add a feature or to debug, and then the product wasn't arranged based on any architecture that is known. So you just envision what will happen, how your mind will be speaking to itself. Things will be messed up, of course. However, if you onboard onto a project and there is a specific architecture followed, you find that things become nice and you enjoy working with that team. So still clean architecture has the benefit of feature isolation, and that I've mentioned. You isolate as to features. Login is separate from products, is separate from cart. Okay. Okay, someone would also say, because we are talking of clean architecture, but then why feature-based? Why don't we scatter our screens and we choose feature-based? For example, you say feature auth, you ensure that whatever relates to authentication is in that directory. Feature product, whatever relates to the product is in that directory. For example, you can see here, let me go to features. Features is here. So why feature-based? You arrange as to feature auth. Whatever concerns auth is what you're seeing in here. So it means that in case there is a bug with authentication, I don't need to go to products feature. You see, in product, I go straight away to auth feature. And there I can decide to troubleshoot basing on what the error is. It makes work very easy. Independent, and then easier to maintain, easier to scale. Let me try to go through this structure. So at the root, we have the main. This is a main method that by default is what that will base on to run the project. Okay, then we have under lib, we take that first line, app. Okay, and in this app directory, we put my app.dat file. This one is the one which contains the material app. Then the router, this correlates to the way we are going to navigate across the different pages. Then we have the theme still in here in the app. We have the theme directory or theme folder. Now this one has our colors, it has the text styling, it has the dimensions. For example, in these app dimensions, you may have set your default padding, and then maybe the shadows. These are all your files that relate to the theme of the application, the appearance of your application. And we have the configs folder or directory. And here you have all your configuration files. If you are having different flavors like dev, prod, so depending on the requirements by the organization or the product you're working on, It's not mandatory to have all these, but I'm just showing you how you could organize your code base. So at the root, we mentioned we have now the app directory. Now we come to the core. So in this core, we have the network directory, and then under the network is where you'll have maybe how you're getting your data, how the data is the API is communicating. We have the API client, the DO client, the endpoints, depending on how you've set up your product, and we shall come to this when we do the practical. Interceptors, token interceptor, logger interceptor, retry interceptor. For example, you're making a request, a network request. The header requires to include the token. So we need the token interceptors or the logger interceptors if you want to intercept the request, the response. So all these can happen in the network directory. Under network, you could have some responses. The network response, you may have a custom network response that has the data of a given type, the error, which is the error message, and then maybe extra. So you could use that as your default response data. We have exceptions, we skip that. So after network, you still follow the same line, but under core, we have the database. You put all that relates to your databases. Then we have storage. So still we are under core, a directory. Services. So you have errors. You could organize it like this because under core you could have errors directory. If you have maybe your custom error handler, and then we have the util. Still under core, we have the utils. Utils would be those methods that you want to use throughout the application. Maybe you have in your application, you have in gender, which is male, female, depending on how your requirement is. You could have formatters, validators, like you're validating inputs. Instead of having validators everywhere spread throughout the application, you could have it centralized and then you reuse it. So you realize that you are making something reusable, and in the end, if there is any bug, you have a specific file where you go and fix that. Extensions, mixins. As I mentioned, you don't need to have all these. So you have use cases, constants. That one marks the core. After core, we could have shared. After shared, we have okay, you may read it as L10N, but it is read as internationalization. Internationalization is where we put all the files that relate to us being able to ensure that our application can load in different languages. Now we come to the key. Here we have features. So if you have a shopping application with clean architecture where we are arranging by feature, you realize that doing so makes your work easy to maintain and understand. So we have the auth feature. Okay. After auth feature, we follow the same line. We have the product feature. But let's look at the auth feature now. So I said auth feature. That means anything relating to authentication is found in this directory. Yeah, under features, you look for auth. Then we structured it into data. You follow this line. After data, we have the domain. And after the domain, we have the logic. And then the UI. So we can say that under data, you have your data source. Maybe data is coming remotely, or data is coming locally from the local storage that you have, maybe Hive and so on. Then still under data, you could have the models, the requests, the responses, the entities. Okay, those are the models. You could have your request like the login request, register request. Then you could have your responses, auth response, user response. In models under data, mappers. So the mappers are generally used to map the models from the API with the models of the domain. Usually, we do not present the model from the API to the UI. Doing so makes your application tightly coupled between the API and the UI. So to avoid that, you create your mapper. This function will map what you call maybe user ETO to the user in the domain, so that you present the user in the domain, not the user in the data from the API. The reason, the user from the API may have very complex structure, but you can easily map that into a simplified structure as to the user in the domain, so that you can display the user in the domain to your UI. Then still under domain, we have the repository, but then we have also the repositories under data. This is what I need you to note. The repositories under data, this, and the repositories in the domain. The repositories in the domain are the methods that don't have implementation. For example, fetch user that returns a list of users. There is no implementation. So those methods are implemented in the repositories of data. Now in that, we don't call them interfaces, but you create it as an abstract class. That's the domain. And still in the domain, we have the use cases. So it is generally it is the use case that will give you data to your logic. Yeah, it is going to give data to your logic because it will get the data from the repository. After the domain, we come to the logic. In the logic is where we have our providers, the notifiers, the states, depending on the state management approach you're using. If you're using blocks, then you would have qubits here. Now, after the logic, we need the UI. Someone would call UI presentation. So here we need the pages like the login page, and then we have the widgets like maybe the login form. If you separated the form from the login page, and you could have other components still under here. So you find that by understanding the auth directory this way, you already understood the product directory here because it's a repetition of what is expected in the auth. What varies is the content inside, but we have data, domain, logic, UI, as brief as this. Then you check another feature, which is the cat. We have the data, domain, logic, and UI. You know what is in the data, you know what is in the domain, you know what is in the logic, and the UI. Still under order, the same. So you see that they have arranged everything as to feature. You have an issue with the checkout, you know where to go. Payment, there is a bug in the payment flow, you know where to start from. There is a bug in the profile, everything is clear. Thank you for watching, and do not forget to subscribe to Code with Kamira. Bye.